To introduce myself, I am Todora Vladic, RAN software engineer in OAI for more than 2.5 years. Thank you for turning off the microphone. So, as I said, software engineer in OAI for more than 2.5 years. My main focuses are at the Flex rig, which is our own implementation of the near real-time rig, and the XApps, as well as the E2 agent emulators. So I'm a maintainer on that side, and in parallel, I'm the main person for the Fronthaul specifically, which is basically the 7.2 interface between the OAI DU and third-party RUs. Among the main tasks within the Fronthaul topic, I developed the management plane from scratch in the OAI DU, and that is basically our main topic for today. So the Fronthaul management plane for between the OAI DU and the third-party RUs. On today's agenda, we will briefly see the general M-plane architecture as per M-plane specifications by ORAN, of course, and we will see briefly the OAI implementation of the M-plane. I will showcase a brief demo regarding the configuration of Benetel RAN550 RU by the 7.2 CUSM interface. And then I will explain in detail message exchange on the Fronthaul. And then I will present a live demo where I will showcase the distributed antenna array configuration. Then we will take a look at the M-plane status, what has been implemented, what is ongoing, and what is the plan for the future. And of course, at the end, we will have, I will share conclusion and some tutorials that you can reproduce in your own labs, and of course, the questions at the end. So why do we have M-plane? The thing is, the manual configuration of the ORUs can become a challenge without the M-plane because of the inconsistency of vendor-specific settings for each RU. Currently, in our labs, we have several different different RUs from different vendors that I will say in more details a bit later. So with the M-plane, what we can do, we can manage and control the configuration of all without the manual intervention. And on top, we would have, we can have as SMO, which can do a centralized management that will enable, that can scale large networks and with multiple DUs from different vendors, as well as the multiple ORUs. And in OAI, the communication between the OAI DU and the RU is literally streamlined. Once you start the DU, the RU will be automatically configured. And which provides basically a foundation of for this dynamic source adjustments. So let's take a look at the general M-plane architecture. We have hierarchical and the hybrid. As we can see, the difference is that in hybrid, the SMO can configure the ORU directly, not only through the DU, which we can also call the O1 interface, which also OAI has. So the M-plane is defined between the ORU controller and the ORU itself. The ORU controller can be a DU or SMO or any other network management function. The main functional features of the M-plane include startup, from turning on the RU to available in service, the configuration management, entire CU plane configuration, the performance management, with which we can retrieve some measurements and counters related to the RU operations. Also, we can have fault management regarding the alarm notifications. Let's say the RU is not reachable anymore, or the power is too high. It's alarming. So we should better just stop the RU transmitting anything, to be in the, let's say, idle mode, to avoid any breaks inside of the RU itself. The file management is basically related to the file transfers, some logging, also beamforming, which OAI supports as well. The software management is basically to just download the new available releases and upgrade within just 1 or 2 commands via the M-plane. What the M-plane uses. So if we take a look at the protocol stack, we can see on the top we have a netconf, which is network configuration for the network management network management protocol, which is standardized by IETF, and uses the Young models, which Young basically is a data modeling language for the definition of data sent over the network management protocols. So, which means that the RUs that follow M-plane specifications easily streamlined, whether it's one RU or multiple RUs connected to one DU. The DU will not have any problem configuring the ORU without the manual intervention of the user itself, if the M-plane is implemented properly. So what the OAI focuses is the Fronthaul management plane. And on the right, we can see the asynchronous notifications that can be transmitted over the via HTTP. However, this is more the SMO functionality than the DU itself. So this is for the future, when an SMO vendor is interested in collaboration with us. The overall view in OAI regarding the M-plane, as you can see, last year we had integrated 7.2 CU planes, of course CUS, but here it's just a synchronization plane is put aside from the picture because the focus is just the configuration of the CU planes. The OAI DU is interfering with integrated with the Extron library, which is the library developed by OpenAirInterface Software Community, that uses a DPDK for virtual functions to transmit CU plane packets. And regarding the last year's architecture, what we have achieved is to integrate OAI DU with multiple ORUs, such are VVDN Generation 3, Foxconn, Lighton, both FR1 and FR2, Benetel, both indoor and outdoor units, the Metanoia, and with both E and F releases of the X-RAN. However, this year in 2025, we can claim that we have a management plane as well. There is only one additional library itself when compiling OAI DU, which is called the ORAN FH lib 5G M-plane. It's just an extension of the existing ORAN FH lib 5G with the netconf client, which is used for the M-plane. So what we only need from the DU to know about the RU in advance is the RU IP address, so it can create an SSH connection via the M-plane to the ORU. Then it has to know the VLAN ID on which the CU plane C and U planes are configured for in the X-RAN for the virtual functions, the DU MAC address, and of course the U plane configuration, which is just transmitted and calculated within my own netconf client. It's very streamed that you can see in my demo on the next slide. So the demo that we presented this year in MWC in Barcelona in February consists of the whole disaggregated RAN, which includes, of course, 3 GPP splits E1 and F1, as well as the NFOPI, which is the interface defined by small cell forum. We have a core network as well, and from the OAI DU low, we connected to the Benetel 550 indoor unit via the CUS M-planes. The radio configuration consists of the numerology 1, standard TDD pattern, 3 downlink, 1 uplink slot. We will see the change of the bandwidth from 100 to 40 megahertz via the M-plane. And what we will achieve at the end, we will have 4-layer downlink and 1-layer uplink MIMO. And all of this is in the band 77. So I will start the setup deployment is configured on the 100 megahertz bandwidth, numerology 1. Then we will connect all the components of the OAI. We will check the throughput with 1 UE connected. Restart the DU high and low for 40 megahertz, and Benetel RU will be automatically reconfigured via the M-plane, and then we will see that the throughput is correspondingly lower. So here is the demo video. Here we can see that I already started the OAI core network, and now we will start the OAI CUCP and the CUUP. Here we will track the logs of the CUCP, and here the CUUP. At the same time, we will check the RLC statistics. And here we will start the OAI DU high for 100 megahertz, which basically is the MAC and RLC layers. And of course, since it's 100 megahertz, the bandwidth, we see that we have all 273 PRBs available. Here we are tracking the M-plane logs of the Benetel RU. Here we started the ODU low, which hosts, of course, the L1 high. And we will start the M-plane service as well. And now if we take a look at the logs, we will see that it connects to the ORU via the SSH. Then it gets the operational data store, like the capabilities of the ORU. It checks if it's the BTP synchronized. Then it subscribes to the notifications. We store some data for the XRAN that we have to configure the XRAN later on, which basically we need the RU MAC address, the MTU, which compression we will use, etc. And now we see that we have packets receiving. This is 4x4 for transmitting and for receiving antennas. And now we will start the UE. It's the Quectel module. It got the PDU session, as you can see, the LCID4. And now, sorry. And which can be also seen by the GTP user plane tunnel in the CUUP logs. Now we will start the hyperv traffic on the uplink. This is the UDP traffic for 70 megabits per second. And approximately the maximum is around 65 megabits per second for one layer uplink. But of course, we are able to do two-layer uplink with VVDN RU, which leads to 120 megabits per second. Now I will start the downlink UDP traffic on 100 giga. We can even see the retransmissions on the uplink. Now I will start the UDP traffic on the downlink. We set it to 200 megabits. And as you can see now, we have a rank indicator set to 2. And of course, we see that the throughput is lower. However, it's a bit higher than 200. As you can see, we don't have retransmissions on the downlink. But this is it was just a test. But of course, it is more towards 400, 450 for 2 layers. And now we can stop everything, and that would conclude the first demonstration. Let's take a deeper look at the M-plane exchange. So at first, we did not see this, but we have DHCP server running in the background, which dynamically assigns the IP address of the ORU. That is a precondition for M-plane. Then we do the SSH connection via the netconf. We retrieve the RU informations. We check the BTP synchronization. We subscribe to all notifications. We update the supervision timer because the RU must be in supervised mode in order to activate the carriers. Then we store some information that is needed for the XRAN, and some RU plane info that is needed for creation of the new configuration for the user plane. Then we load the young models that the ORU supports. And based on that, the DU performs the CU plane configuration via the edit config RPC. So the interface, the processing elements, the user plane configuration for each antenna port, PDSCH, PU, SCH, and PRACH, the carriers, the center frequency on both of them, the bandwidth gain, etc. And in the future, we will, of course, expand to the category B ORUs, which is currently under development in the OAI. Then the DU checks if the CU plane configuration is valid. If yes, then commits the changes. Then the DU waits until the RU is ready. Once ready, the DU configures the XRAN and the DU RU exchange packets. Now we will take a look at the live demonstration that I will showcase now. So in the previous demonstration, we saw the bandwidth change. Now we will see that we are able to handle multiple RUs simultaneously. So what I will do is connect two Benetel outdoor units. 650 is the outdoor unit. Each 4x4. In total, it's 8x8 configuration from one OAI DU, and we will use 100 megahertz bandwidth, same numerology 1, same TDD pattern, and we will see here for the outdoor unit, the maximum is 3-layer downlink and 1 uplink with Benetel. And what we will see recently, what we did is we implemented the performance matrix notifications. So the previous demo was recorded in February. We only saw the startup and the configuration management, but now we will see also the performance management. So let me start. Here I have one RAN550 RU, here is the other, and we will track the M-plane logs. On our server, I will configure 4 virtual functions, 2 per each RU. They have different VLANs, of course, and we will have 4 virtual functions configured on the XRAN, 2 for one and 2 for the other ORU. So I will start now the NRSoft modem. This is a DU only. The CU is already running in the background as well as the core network. So I started, and then we can see that the OAI DU already connected to the first ORU, which is the .5 is on the up right corner, and .6 IP address is on the low right corner. So what we do, we connect the same message exchange as I explained in the previous slides. Connect, we get the operational data store, we subscribe to notifications, we go inside of the supervision mode, and what we do is store some information that is needed for the XRAN. This is the MAC address of this RU, and what we will configure on the XRAN as well is BFP compression of 9, static BFP, with the patch offset can be anything, but we chose to be 4 to not overlap with the push. Here we are loading young models. Due some inconsistency inside of the RU, we're not able to retrieve all of them, so we loaded them statically from the OAI repository itself. And based on all of this information, what we do, we create a new interface with the a specific VLAN ID and the RU MAC address. We created the performance measurement objects, which is currently set to false because we needed to first activate the performance measurements inside of the RU itself before we actually turn it on. And of course, what we see here is a processing element that contains the DU MAC address of this server itself, the VLAN ID again, and of course the RU MAC address to combine everything in one processing element. Here we start the user plane configuration that links the antenna ports and the carriers. And as you can see here, we have the first takes a transmit antenna. We set it to BFP9, the static compression, and some additional information regarding the cyclic prefix, etc. And what we can see down is here we what we can see here is the TXRX carriers activation. And we can see that we are trying to configure on 100 megahertz bandwidth. And if we take a look at the logs of this first ORU, we will see that bandwidth of 100 is already configured because it was a default value. And then if we check the DU logs further, we saw that we validated and committed the changes, and we received some notifications from the ORU. For example, here we see that the RX carrier is busy. That can be seen here as well inside of the ORU. If we scroll down, we will see so many changes because we changed all the antenna ports and the MIMO mode. Here we started to configure a second ORU, which I don't need to go in further details because it's exactly the same. And once the RU is ready, so we have the first RU is ready, then we can actually activate the performance measurements, and we can see that here we change the active to true. Here we have a second ORU trying to configure the same measurements for all the available measurements, basically, that we retrieved via get RPC. We got notifications from them that now we have to replace the active state in both of them. And if we scroll a little bit down, then we will see that we started to configure the XRAN, the VFs. As you can see here, we have 4 VFs, 2 per each RU. We configure one for one RU, the second RU, and now we can see the packets for 8x8. This is for the push and patch, and we are transmitting here on the PDSCH. Now, if we scroll all the way down, you will see that we occasionally receive this measurement information. I set it to 15 seconds, which can be also seen in the logs itself. So here, basically, we have a difference of 15 seconds. Now I will start the UE, the Quectel UE. We will connect. So all this equipment is on the roof of Eurocom. So right now is running, it's live. And here I will start the iPerf traffic for downlink, for UDP traffic on 500 for 550. And we can see the maximum of 3 layers. And CQI is a bit low. In ideal time, it would be ideal case, it will be 15, but now it's 11. It's a outdoor deployment, so it's a bit expected. Although we use 256 QAM modulation. And if we run the uplink traffic, I will set it to 100 megabits UDP. We see that we transmit on the uplink as well. However, the 100, it cannot be reached. So we can see here the uplink retransmissions. So around 55 is the maximum for the outdoor. So if I try to, stop the UE, as you can see here on the M-plane logs, we still are sending the performance measurements. However, when I stop the UE and I stop the DU, it will deactivate the performance measurements. So as you can see here, when the signal is being caught, we will send the performance measurement deactivation to the ORU, and as you can see that the ORU successfully retrieved the measurement change. So this would conclude a live demo, and I will continue with the next slide, which is the current M-plane status. What has been implemented, as you can see, the startup procedure, the configuration management for CO planes, and very recently the performance management. That's basically the counters of the Fronthaul counters related to the RU operations, if the packets were received on time, late, etc., as you already saw. The ongoing is the default management to see the alarm notifications. If something happens to the ORU, we need to react fast and either shut down the RU or see how can we overcome breakdowns. And what can be done in the future is the file and software management that are important as well for large networks, and especially from the operator perspective, from the SMO perspective, when it has large network, and to see the network performance. So this would conclude my presentation. What we saw is the successful M-plane integration in the OAI RAN. We have now fully operational O-RAN 7.2 interface. As per specifications, we are fully compliant with the O-RAN and, of course, 3GPP. And we saw that we can automatically reconfigure the ORU without the need for manual intervention. And we tested successfully with the Benetel indoor-outdoor units, as well as the Metanoia ORU. We saw the different MIMO modes with the live demo of distributed antenna array, and the bandwidth with the already recorded video that we reconfigured from 100 to 40 megahertz bandwidth. And we also saw the successful reception of performance counters. And from now on, OAI proudly invites the SMO vendors to work with its M-plane implementation, and so we can showcase all together the full network automation. The available tutorials are already in the available in the OAI RAN repository. So it is here in the develop branch under the doc O-RAN FHI 7.2 tutorial, and we can see, we scroll down, we have also the management plane. It uses the XRAN, which is the O-RAN software community developed library. We can also go inside of the tutorial for that as well, that we followed and integrated with the OAI DU. So that would conclude all my presentation, and I'm ready to take your questions.
Thank you, Theodora. So, yes, go ahead, sorry.
In VVDN RU, we do not have a Benetel RU, but how is the M-plane implementation status in OAI regarding different RUs? Specifically regarding VVDN 7.2 RU.
With the VVDN, we still haven't showcased full M-plane capabilities. There would be needed some workarounds in order to be fully automated with the VVDN RUs. However, if you are interested to work on the M-plane with the VVDN, I would be happy to give you any support you need.
How can we get in contact regarding this?
Sorry, can you repeat your question?
Yeah. How can I get this support, ma'am? Do I have to contact you on the mailing list or something?
Yes, or you can just contact me on my email directly, which I will share right now on the Slack. On the chat.
Okay.
And
thanks,
you are. Thank you, Ritwik. You are from which lab?
We are in lab based in India, in IIT Delhi.
Oh, okay. Okay. Well, I'm really glad that we are expanding there as well. So if you have any suggestions, and we can work on it together regarding the VVDN RUs and make it interoperable with OAI DU. And I just shared my email address. Yes, no problem.
Okay, thanks, Shiro.
Okay.
So I have just a question. Hello, I'm Guillaume Grau from Orange. There's a different version of the specification of M-plane. Could you, maybe you said it, but maybe I didn't hear it. Do you know what version did you implement? Oh yeah, okay, thank you. So it's a V4, I say?
Yes, regarding the M-plane specifications, it's the version 5.
Okay.
However, we have recently received a new Benetel release, 1.41, that is compatible with version 16.
Okay.
So we are also looking into the M-plane of that new firmware. Currently, we're just need to get the license in order to test. But I wanted to say we will upgrade the M-plane version based on the RU support.
Okay. Good to know. Thank you.
And the current Benetel releases that we have that I showcased is 1.21, sorry, 122. Yeah, let me share in the Slack chat. 1, 2.
Maybe another question. So you talk about integration with noted VVDN Lighton. Did you do the same thing with the Foxconn ORU?
With the Foxconn, no.
No. Okay.
No, with the Foxconn, no. However, with the Lighton, I got their latest firmware version, which is 2.1.4.
Okay.
However, I was so close to test it with the M-plane, but however, somehow the Lighton lost its PTP synchronization, so we had to disconnect from our network. But yes, I will test with the Lighton.
So Orange side, we will be interested by that because we have a Lighton, so we want maybe to test the M-plane with that.
Probably for some European projects, I think. Yes, good.
Thanks.
Hi, ma'am. It's Daksh from W4S. So our startup is basically incubated in IIT Delhi, and we are also working on OpenAirInterface. So we are currently working on 7.2 split, and we have VVD and RU with us. And I just want to confirm that instead of Benetel RU, can we use SDR, any NI or Lime SDR if possible, to configure this and to just test this M-plane configuration?
No, it must be with the real 7.2 radios.
Okay.
For example,
in that case, instead of Benetel, can we use the same documentation for VVD and RU, or still workaround is left?
The workaround needs to be implemented. I did test in the past, but I remember it deviates a bit from the specifications. And I needed to work to finish the M-plane implementation in the OAI DU. So I didn't focus at the time on the VVDN, but right now,
noted,
yes.
noted, no problem, ma'am. Okay, understood, ma'am.
Yeah.
And ma'am, I also want to confirm what is the maximum throughput which you are receiving currently with the Benetel RU in 4x4 and in 2x2 also.
Downlink Benetel 4 layers is around 950.
Is it calculated or is it actual received, ma'am?
It's received.
Okay, then it's fine.
Yes, it's received. It's received.
Okay.
But with VVDN, I know it's higher, 1.2 megabits per second. And with the T2 card, it's I think a bit higher, even a bit higher, because the T2 card does the LDPC offloading, so the processing on the DU is
because
faster.
we are not using any hardware accelerator as of now.
All right. All right.
Thank you, ma'am.
Okay, do we have more questions? I think there was a question in the chat if you want to take it, Theodora. It's a question just above the comment of Wish, Felipe.
1 second just to see.
Just go down a bit. Yes, again down. Yes, this is this one in pink. You have it on your screen. It's pink.
Oh well, this is regarding the E2. Well, it's not the topic of our webinar, the E2 and the FlexRig. So I would honestly ask you to just share your logs on my email, so I can help you better, because right now I can see that there's no E2 connected. Yeah, sorry, the E2 agent connected, or the near real-time rig crashed. I mean, there can be several cases. And if it also depends if you deploy on the same machine, or you have on the multiple machines. That on one hand, on one you have the near real-time rig and the other E2 agent. So I would really ask you to send me the email, private email on my this email address that I shared, and that I can help you better. So.
Thank you. There's another question in the chat, which is, what are the configurable parameters that M-plane can support?
What are the configurable? So the MIMO mode, the bandwidth, the center frequency, the transmit gain, what's the name? The compression. It can be no compression with 16 bits for the IQ samples. For example, you can, yes, for the PDSCH and push channels and PRACH, you can, sorry, for the PUSCH and push and the PDSCH, the antenna ports must start from 0, because that's the limitation of Extron. But for the PRACH configurations, you can do anything that interests you, even from 0 or whatever value. So there are many layer 1 parameters that you can modify. And I just showcased the bandwidth change on the same frequency and the MIMO mode. But yeah, there are many. So maybe you can specify your questions more thoroughly, so I can tell you yes or no immediately. It is, I mean, that can be configured. I said,
Theodora. Yeah, this is Abhishek Saurabh from Qualcomm. I'm also the co-chair and for Working Group 4, one of the vendor co-chairs. What I just wanted to add to your response on configurable parameters, I just wanted to mention that, as you said, the question has to be more specific, right? When it says configurable parameters, yeah, my understanding is it is ODU configurable parameters. So the M-plane, every parameter which is read-write, right, in the Yang model, each of those parameters can be configured by the ORU controller, right? And as you said, that's a range of parameters.
everything that is related to the configuration management and performance management can be configured from the DU perspective. However, there are some limitations. I know that some of the things I think are not allowed for different users. I use it as a default user. I use with sudo privileges, so all of them included. But the SMO, I think, has limited configuration changes. If I take a look at the spec, let me actually check, because I know there is a table at the beginning of at the beginning of the spec that describes what are this read write. Wait 1 second. Okay, I didn't apply the filter. 1 second. Wait.
So maybe this can be discussed offline. I believe I had a separate question for you. What I wanted to understand in terms of OpenAirInterface, is there a implementation roadmap that that I can refer to? Implementation roadmap in terms of what I saw was version 4 or version 5 of M-plane was supported in the software demo, if I'm not wrong.
For M-plane version 5.
Right.
And so the roadmap is available on our main website. And we stated here the configuration management version 5, and right now, as I said, performance management version 5 as well. And for quarter 4, what we planned is also fault management, implementation from scratch, and the update of the existing configuration and performance management to version 16. As I said, the new Benetel release supports version 16. So that's what we are aiming for.
Okay, wonderful. Thank you. This is useful information for me.
Yes. And regarding the spec and what exactly, if you want me to reference all the features from the M-plane specifications that can be configured from the OAI DU, I can do that offline, and Camille can transfer to all of you email to know exactly what OAI can configure today and what is being planned for the near future or further future. Is that okay for everybody? Is it okay for you? Abhishek, is it okay for you?
Yeah, good for me. I know the table you are referring to. You're referring to the NACM table, so I'm aware of that. But yeah, I think any such information, maybe we can sync up offline in the email. Thank you.
Thank you. I see that there are some more. Is there any specific kind of Intel processor? We use 810 and 710 NIC cards that we tested with, and it is actually specified by our documentation at the beginning. What we do have. Okay.
No, yes, ma'am. Sorry to interrupt in between. I just have a quick question regarding this NIC card. I do have E823-L, So basically it is Intel Xeon D series. So is it configurable in that also?
I would need to check that with my colleague. Can
Sure,
you just
sure.
repeat?
E823. E823-D. E823-L. L for London.
Okay.
Sorry.
Hyphen. Yes. Okay. Okay. I will ask my colleague.
Okay.
I'm also facing some kind of issue. Basically, it is a 25G card, and I'm also working on it. So that's why I asked this question.
With 25 giga, it can work. It will work. Even multi-RUs can work with 25 giga.
Okay, ma'am.
Okay, Theodora, I think we can answer the last three questions. There's one question from Kenny, another from Dr. Rafek, another from Kenny. And then we can maybe stop.
All right. So regarding the question from Kenny, what kind of performance-related information can be retrieved from the RU? It is all what RU supports, which is currently the received packets on the downlink, on time, early, corrupted probably. I don't have a full list. Well, actually, I do have here. So this is currently what it can support, what the RU supports. So the DU doesn't go into details about this. It just retrieves whatever the RU supports and questions to get notifications for those objects. Okay, the next question, could you clarify whether the OAI DLO can be connected to multiple RUs? Yes, I already did a live demo with the two RUs. Whether it's the DU low or just the DU standard or G0B, whatever the OAI implementation of the base station. So yes. And do the C-plane, U-plane, and planes all share the same physical fiber? I think yes. I cannot remember, to be honest. I haven't been in the lab recently, but yes, because it is connected to the same switch. Yes, it is connected to the same switch, and the S plane basically checks the PTP synchronization that is received from the on the switch. Yes, the one. Yes, it is the same fiber. I remember now. I have to leave. Okay. Okay.
Yes, I think we are at the end of the questions. So thank you so much, Theodora. Thank you for everyone that joined and listened. And I hope that we'll see you again in the next webinar. Thank you, everyone.
Thank you.
Thank you.